Yeah, hi everyone. So I'm going to talk about how NESP research is informing the reporting of gully remediation in the Great Barrier Reef report card. So NESP, as Rebecca and Scott have described, has conducted a lot of field research experiments, and there's been a significant team there. My role has also been as a part of that team, but also leading a technical partnership supporting Reef Trust and its erosion control programs. And that's a collaboration between CSIRO, Griffith Uni and ANU to deliver consistent technical advice on erosion control so that the industry has the confidence to invest in an ongoing way. And that involves delivering this toolkit technical guide for practitioners to use that directs support to projects as they implement their projects, and then also evaluating the program. So this is how the NESP research has been plugging into industry practice. A big part of that has been to develop a framework to estimate the sediment reductions which will be delivered in coming decades from controlling gully erosion, such as this feature in the Fitzroy, which has a large runoff diversion bank installed around it. So the framework accounts for the possibility that gully erosion will decay with age naturally without treatment over decades. And then it also uses the climate signal to correct for any annual variability in sediment yields. So we're looking over decadal timescales to get a mean annual picture of the recent period erosion and then how that corrects through to the future in the coming 30 years, which is the baseline period that we're taking. And then, of course, we want to predict what's the decline in the reduction in sediment yield. And so once we've got the volume accounted for, we also then look at the soil, silt and clay content, and we account for the effectiveness of the erosion control as a proportional reduction in from the no treatment baseline. And then also the sediment delivery from the site to the coast. So this is what has enabled a kind of consistent translation of research results to industry practice and the report card. So yeah, it's been a multi-stage process, and I think it's fair to say our communication of that has been working alongside of the development of it as well, and so now we're getting to the point of having apps that people can do this work in a more consistent way. So as I mentioned, the sediment reduction is the product of the baseline yield multiplied by the effectiveness percentage. And so what we've known from Reef Trust early days was that the baseline erosion rate varies a lot between our sites. And these were just back of the envelope calculations. And so different gullies were forecast to erode in different ways. And essentially NESP has been testing that as a hypothesis, whether they really are that variable. And the other thing we've been working on is the effectiveness percentages themselves. So in the toolbox, we provided effectiveness values which represented expert opinion based on global review. And so at the start of NESP, there was really no quantitative studies of gully erosion control effectiveness in Great Barrier Reef catchments. And so these are some of the common activities which are being funded. So in terms of the research findings, firstly, as Rebecca mentioned, that the baseline yields really are very variable. So for example, the gully on the top had less than a fifth of the sediment yield to the gully on the bottom. And so that means that targeting high yielding gullies is really important if we're going to deliver rapid water quality improvements. And so then we did some experiments on individual erosion control practices to look at their effectiveness. So for example, grazing control was found that, so the toolbox had a 10 or 20% reductions. And what we found from our research across different sites was that after 15 years of actually changing grazing practice, so that middle site, we changed grazing practice, we couldn't actually detect a change in the erosion rates at that site. However, if we took the extremes, the right and the left photos, if we looked at landscapes which had on the right, we'd had grazing exclusion for more than 20 years, and those gullies were eroding at less than half the rate, delivering less than half the sediment of the ones on the left. And so I guess the take-home was it depends on how long we're prepared to wait for sediment yields to decline from livestock grazing control, and also on the starting degree of degradation. The more degraded it is, the longer it's going to take to recover. But having said that, grazing control remains an important activity which supports revegetation after more intensive measures. So another one was check dams. So we put in some check dams into gullies and we monitored the sediment yield. We constructed a sediment budget, and the toolbox was forecasting that these would be on average 40% effective. What we found at the research sites was actually more like 10 to 20% reduction in fine sediment yields, but really good at trapping coarse sediments and really good at stabilising the bed of gullies. So this changes the guidelines for their use in future programs. Diversion banks were found to actually be more effective than the toolbox estimate. So that's provided the runoff that's diverted is safely disposed without causing further erosion, and that they're constructed really carefully so they don't fail in large events. And gully reshaping, 60% in the toolbox, we found that yes, it could be more effective than that, provided there was good control of livestock exclusion, good ongoing cover management, good repairs where needed, etc. So we've revised some of these effectiveness estimates. At this stage, these findings will now be used alongside other research which Andrew Brooks and others will be talking about as well, to develop updated effectiveness values in the third edition of the Gully and Streambank Toolbox, which will come out early next year. And they're already being applied in some certain very comparable sites. The trick is that translating research results to industry practice isn't direct all the time. And so I'm going to just talk a bit about how the considerations that we take for that. So firstly, back to the impact of having really variable baseline sediment yields, we now know that it's really important to assist targeting of the most active gullies. So we've been developing algorithms to map gully extent from LiDAR data, and then to assess the potential expansion of each and every gully head. In terms of the effectiveness, there are two big things we need to consider. The first is the difference in the timescale. So research and monitoring, typically of the order of 3 years duration, but the program evaluation, we need to lock in the water quality improvements for at least 30 years. And so there's a higher risk of extreme events, and there's an unknown degree of maintenance of vegetation cover and maintenance of engineering structures and fencing, etc., over those longer time periods. So typically, smaller default values of effectiveness would be used as a standard application for erosion control programs rather than the research sites. The other thing is a difference in spatial scales. We need to be careful that, so for example, the research site effectiveness values often only apply to a subset of the gully, not to the whole gully. And so the industry site effectiveness that's applied as standard needs to be only applied also to the treated parts of the gully. I should mention that as these projects are rolling out, they're also doing what we might term bronze level monitoring of the implementation, and that monitoring can also help inform some of the revisions that are going to be made to the industry guidance because they have such a large coverage in terms of site numbers. But there isn't a need for some ongoing research. Research is what enables adaptive management. It's the practice and the research going together. So the blue boxes on the left are ways that research can inform evaluation, adaptation and vision setting in erosion control programs, alongside of the community vision for managing these landscapes and for achieving the water quality outcomes. And also there are new knowledge gaps emerging as we roll through these erosion control programs. So stream bank erosion control has become much more prevalent activity. Site maintenance, now that we have a growing number of sites, is becoming a bigger issue to understand. Nutrient yields from erosion control sites and how much we're improving the nutrient loads in rivers. And also the landholder perspectives as we move into cohorts of landholders who've actually had less engagement with delivery, with extension and other water quality programs over time. We need to understand more about the landholder perspectives and how to integrate the work with their land management. So in short, industry doesn't stand still and we need to keep moving along with it. So to wrap up, NESP research is improving the certainty of investment outcomes and also enabling adaptation of what we do in these erosion control programs. The Gully and Streambank Toolbox is connecting the erosion control research into the practice. Targeting active gullies is a real key to cost effectiveness and to maintaining the pace of and improving the pace of water quality improvement. Effectiveness of erosion control is now much better understood. Ongoing monitoring will deepen our understanding and knowledge of how these sites perform in the long term. And it's important, of course, that our biophysical understanding is shared with community and integrated with other values, climate, biodiversity, carbon, productive land uses. So, yeah, thanks very much. We'll leave it there.